Well, hello, Yanan. Welcome to your homework feedback video for the ninth homework of the year on physics. Similar as always, please get your green pen. Please write down the correct answer in green to any question you got wrong. Give yourself marks to the question you got right, and make sure you bring your homework back in class when it's due. Let's start straight away. Do this within less than 15 minutes. I'll attack. The diagram X, Y, and Z show the particles arranged in three states of matter: solid, liquid, and gas. Which one of the diagram show the arrangement of particles in a liquid? And it's going to be Z. Remember, in a liquid, the particles, touch each other, but they're not in a regular arrangement. So this is Z. They're able to flow around each other. Here we are. Which one of the diagram X, Y, or Z show the arrangement of particles in a gas? So do remember, in a gas, the gas particles have no interaction at all with each other. They're moving in random direction. So it is going to be X. Y is a solid, or the gas particle, or the gas, not the gas particles, where the particles are touching each other in a regular arrangement and are not free to move at all. Draw a ring around the correct answer. In a gas, the particles are moving randomly. It means they all move at different speeds in different directions. In a solid, the forces between the particles are stronger than the forces between the particle in a liquid. And that's why in a solid, the particles are not free to move. They're stuck in position. Okay, it's because they're so attracted to the particles around them. In the liquid, they're still attracted, but not as much, which means they can move around and not just vibrate. The picture shows a puddle of water in a road after a rain shower. During the day, the puddle of water dries up and disappears. This happens because the water particles move from the puddle into the air. What process causes water particles to move from the puddle into the air? It is evaporation. Okay, evaporation is when substance go from liquid to gas at a temperature that is below boiling point. Okay, so here the water does not have to be at 100 degrees to turn into a gas because of evaporation. Condensation is going from a gas to a liquid. A radiation, you will see later, or maybe you've seen it before, is when heat energy is transferred by a hot object to the surrounding. Next, describe one change in the weather which would cause the puddle of water to dry up faster. So if it was hotter, it would evaporate quicker. If it was drier, it would evaporate quicker. If it became windy, it would evaporate faster. Okay, so a rise in temperature, or if there was more wind, or if the humidity decreased, that would lead to a quicker evaporation. Water exists as ice, water, or steam. The particles are arranged in a regular pattern remember that's in a solid, so in ice. The particles are close together, but not in a regular pattern, that's in liquid water. The particles move quickly in all directions in steam, because that is the gaseous state of water. Which will have the lowest density? So remember, the density is the mass divided by the volume, and in that case it's steam, okay? Because the volume of gas is way larger than the volume of water. Therefore, the gas has the lowest density. For ice and water, it's a bit more tricky, but it happened that ice has a lower density than water. That's why it can float. The image shows an iceberg floating in a sea. We know the mass of the iceberg and the volume. Calculate the density using the equation density equals mass divided by volume. So the mass is 11,200, the volume is 12, therefore the density is 933 kilogram per meter cube, which is slightly less than water. The liquid water has a density of 1,000 kilogram per meter cube, and that's why the iceberg is going to float. Density can be explained using the particle model. The figure below shows particles of the same substance in three states of matter: solid, liquid, and gas. Use the figure above to explain why the solid has the highest density. So if you look, all these states have the exact same area or volume, okay? But there's a lot more particles in a solid than in a liquid, and even more than in the gas. So the solid has more particles in the exact same volume, therefore the solid has the highest density. Next, the particles in a gas are constantly moving. The particles move randomly, again, every direction and every speed. And when the temperature of the particles in the gas is increased, the particles have more kinetic energy. They're going to move faster. Okay. A gas is put into a closed container. The container and the gas inside it are heated. What will happen to the pressure inside of the container? So remember, the pressure is caused by gas particles bumping into the wall of the container. If you increase the temperature, or if you heat up your gas, the gas particles are going to move faster. Therefore, they're going to collide with the wall of the container more often, with more force, and that's going to increase the pressure. And the pressure will increase. Before we do question 4, this is the code. Can you do a drawing of your favorite sport? Okay, so please draw on that page. Make a drawing of your favorite sport. Next, the diagram shows the arrangement of the particles in a solid and in a gas. Complete the diagram below to show the arrangement of the particles in a liquid. So again, when you have to draw this, make sure that all your particles have the same size. Make sure they're all touching each other, and make sure they are not in a regular arrangement. Okay, so there's a lot of possible good answer, but if you look at mine, the particles are touching each other, they're close to each other, they all have the same size approximately, and they are not in a regular arrangement. Explain in terms of the particles why gases are easy to compress. So if you look in the gas, there's a lot of space in between the gas particles. Therefore, it's easy to compress it. Okay. There are large gaps between particles, so it is easy to push particles closer together. Next, the diagram below shows the model that a science teacher used to show her students that there is a link between the temperature of a gas and the speed of the gas particles. The ball bearings represent the gas particles. Switching the motor on makes the ball bearings move around in all directions. How is the motion of the ball bearings similar to the motion of the gas particles? They all move randomly, or they both are random. Okay, here the ball bearings are going to move in every direction at different speeds. The faster the motor runs, the faster the ball bearings move. Increasing the speed of the motor is like increasing the temperature of a gas. Use the model to predict what happens to the speed of the gas particles when the temperature of a gas is increased. The speed is also going to increase. Okay, they have more kinetic energy, more energy. They're going to move faster, but still in random direction. Question 5. Excuse me. Figure 1 shows a diver. Which two sentences describe the movement of the air particles in the canister? They all move in random direction. Okay, and they don't vibrate. That would make them solid. It's not solid in the canister. The motion of all the particles is predictable. Incorrect, because it's random. It's moving in every direction at different speeds, etc. They move with a range of different speeds. Oh, this one is also correct. Sorry, I forgot one answer. They move with a range of different speeds is also a correct answer. And the move in a circular path is incorrect. Okay, so the second and fourth one, I'll try and see if I can. Oh no, that didn't work. One more time. Here we go. And this one is also a correct answer. Okay, next. The temperature of the air inside the canister increases. What happens to the movement of the air particles? Again, they're going to start moving faster. They're gaining kinetic energy when the temperature increases, so they move faster. It could be dangerous if the temperature of the air inside the canister increased by a large amount. Explain why. So if the air gets too hot, the gas particles are going to move even faster, increasing the pressure, and the canister may explode if the pressure was too high inside of it. You don't want that to happen. Okay, this is it for today. Make sure you have all the correct answer in green. Make sure you bring your homework back in class. Make sure you have the right code in your homework. Don't forget to stay amazing, and I will talk to you very soon. Bye-bye.